the motivation for this session was we often get questions on, oh, Graph Studio, Graph Server, Graph Client, what do I need? I'm deploying, I'm using autonomous database, what do I need? Or I am using a database on premises, what do I need? And so we put together this short session, relatively short session, to kind of clarify how the different components that you might have heard in the context of Oracle Graph, to see how they all fit together and what components you would use depending on your use case and the deployment scenario that you're working with. So with that, let's get started. I am Mele. I'm a product manager in the Oracle database organization. I worked with a bunch of different technologies over the years, currently focused on graph databases and graph analytics, and I'm part of the spatial graph product management team. And Denise?
Hi, I'm Denise Myrick, and I actually work for Mele. I'm a senior product manager for the spatial and graph team as well.
Thank you, Denise. We have a standard safe harbor statement, just in case I talk about something that's coming in the future. So many of you might be familiar with Oracle Graph, but before I talk about Oracle Graph components, I thought it made sense to briefly touch upon the features of Oracle Graph. So Oracle Graph is a feature of Oracle database, just like spatial is, like you can have spatial data types in the database, just like JSON is, you can store, query, and manage JSON objects in the database. Similarly, you can create graphs from data in tables, and you can query graphs. So it's an integrated feature of Oracle database. And we support queries, and that helps you find patterns in data. I'm not going to go into exactly what a graph is, but basically a graph is a way of modeling your data, where your data entities or nodes or vertices in the graph, and any relationship between them or edges in the graph. So you just take data that you have in tables and look at it in the form of entities and relationships between them. So when you write a graph query, you can find patterns in data. You can find highly connected nodes. You can find highly connected subgraphs and so on. And we, as you may know also, in Oracle Database 23c, we have support for SQL syntax for working with graph queries. We worked with the SQL Standards Committee to make that possible, along with other vendors. And before that, if you're using Oracle Database 12.2 or 19, you can use our graph query capabilities by using the property graph query language, which is very aligned with SQL, but it is a separate language, and that's what leads to the many different components that you may need if you're using 19c, which you might not need if you're using 23c and so on. So I just have a simple graph query there. The other key feature of Oracle Graph is the ability to run algorithms. There are over 60 algorithms that are available that you can that you can invoke using simple Python or Java API calls. Examples are PageRank that you can see here, and then other community detection algorithms. And you might have heard of Dijkstra's shortest path, Bellman-Ford, all these algorithms which give you the ability to analyze how the entities in your data are connected. All of those algorithms are supported out of the box. And to reiterate again, graphs are a part of Oracle database. When we create a graph, it's created as a view on business data and tables, just like you have a database view. This is a graph view. That makes graphs graphs created using Oracle Graph very well suited for OLTP workloads, like when you have lots of updates, lots of concurrency requirements. Your changes are instantly reflected in the graph. And also because graphs are just a view on your data, you have a single source of truth. Your other applications can continue updating the data. You don't have to copy the data anywhere. The data just remains where it is, and then you're just creating a graph view on this data. And because it's native to the database, it can be used with other data types you have in the database, like JSON, spatial. the new vector data type that's planned for 23C and so on. Database versions, often people ask us, oh, is this a new feature? It is not. We have supported graph, the property graph version, a property graph feature since Oracle Database 12.2. The RDF graph feature goes even further back. And in Oracle Database 19C, that's where many of our customers are. They're using the Oracle Graph feature with 19C. And in 23C, the big feature that's coming is that we have made it possible to use SQL to run graph queries. So you don't need a separate language PGQL, you're just using SQL. Now that's the database, on the database version side of things. You also need tools and libraries to work with graphs. For example, when you're running SQL queries, you download SQL Developer perhaps as a tool to work with to run SQL queries and work with your data in the database. Similarly, for running graph queries, there are some tools that we make available. We have Oracle Graph Server that is needed for running graph algorithms like PageRank that I was just talking about. The Oracle Graph Client it includes libraries, for example, to understand and parse the PGQL queries, which will not be needed, of course, if you're using 23C because the graph syntax will be in SQL itself. But if you're using 19C and you're using PGQL, your application needs the ability to parse the PGQL query and send it to the database, and that and other functionality is part of the Java and Python client libraries. We also have the graph visualization tool that is available as part of these tools and library downloads that is shipped 4 times a year. So you get quarterly updates of these tools. So when we talk about components and versions, that's what we'll see in the rest of the session, how the different things work together, what you need for depending on your deployment and so on. So what are our different deployment options? One, you have Autonomous Database, which is a fully managed service. We have graph features integrated with Autonomous Database. Or you can use Oracle Cloud and use an Oracle-based database service that you install there, or maybe you have Autonomous Database dedicated. And with these options, you can run an Oracle Cloud, or you can run an Oracle database at Azure. That's the partnership that you might have heard about over the last few months. So these are the cloud options. And then we also have, of course, the ability to use a database on premises. So the Oracle Graph feature works anywhere a database can be deployed, whether it's in an autonomous database, as a base database service, or on premises. And as I said, 12.2, 19.3, and now 19C and now 23C are the database versions that you can use. So let's take a look at some of these components that I was talking about. We have the Oracle database. That's the license, by the way, that governs the use of Oracle Graph. If you have a database license, you can use the Oracle Graph feature. Then you have other components like you see here, Oracle Graph Server, Oracle Graph Client, Graph Visualization, and Graph Studio. I've not talked about this yet. So let's see how all of these pieces fit together depending on our deployment. So the very simplest deployment is you just have a database, and this can be a database anywhere on premises, in the cloud, etc. You have a database and you just want to run some graph queries. You can connect a tool like SQL Developer or SQL CL and run graph queries. Of course, when you're using 23C, that is straightforward because you're just using a standard SQL worksheet. The syntax is in SQL. If you're using 19C, you can still use the SQL Developer tool or SQL CL. In SQL Developer, the desktop version, we have the option to use a PGQL worksheet. You have to use a specific SQL Developer version, 23.2 or later. I should also mention that it's not yet available in the new VS Code deployment that they have for SQL Developer. So in SQL Developer desktop, as long as you're using 23.2 or later, you can use a PGQL worksheet. to run queries. So the simplest way to get started is take your SQL Developer instance or SQL CL, either one of the two client tools, point it to the database. And if it's PGQL, use a specific PGQL worksheet. And if it's 23C, you don't have to do that. And in 23C, any SQL tool will work with the database. Any tool that runs SQL, you'll be able to run graph queries. And all of this is captured in this Getting Started blog. And I think that font size is too small for you to see that. But towards the end, I have links to the Medium blogs on medium.com. And you can see here we have a blog on here, so we can get started with Oracle Graph and using SQL Developer. So that's puzzle piece number one. I just want to run queries in the database, and I can do that with any one of these tools. So next, of course, is the interesting thing of how do I visualize graph queries? It's very interesting to run queries, but graphs are very visual because graphs are all about entities and how they're connected to each other. So having a visual representation of that is often very useful. So to do that, the tools you need is you would need Oracle Graph Server. It's part of the tools and libraries that we ship 4 times a year. You have Oracle Graph Server and then you have this browser that you can point to a particular port in the Oracle Graph Server, which will then communicate with the database. So when you submit a query through this visualization tool, the queries are then executed in the database, and then the results are displayed in your browser. This is meant to be a developer tool, so when you can just quickly see how your queries look, what kind of results they give you, and so on. We also have a JavaScript library that you might want to use when you want to incorporate this graph visualization in your own visualization tools and dashboards. So to start visualizing results of graph queries, you would now need to install Graph Server and point it to the database. And this is the blog again on medium.com that helps you do that. That is comprehensive and will highlight how you can set up Graph Server and start visualizing your queries using a simple browser-based tool. And that is so these are the 2 other puzzle pieces that come together. You have the database. Now you're connecting it to the Graph Server, and you get the graph visualization tool. And now before turning it over to Denise for a demo, I'm just going to talk about the use cases. So now we talked about querying graphs in the database and visualizing the results of these queries in the graph visualization tool. So the use cases that are covered by this deployment would be anytime you're just running graph queries. Notice that I've not talked about the algorithms yet, you're just running graph queries. And importantly, when you're having a high degree of concurrency, the database can easily handle hundreds or thousands of users running tens of thousands of queries at the same time. And all of that will apply to graphs. So if you have a scenario where you want to run lots of queries concurrently, then running graph queries in the database using the Graph Server just for visualization works well. So like we said earlier, the graph view automatically gives you the latest data. So you don't have to worry about synchronization or anything. All your data is in the database, your graph view is in the database, you're querying it with familiar tools, and you're visualizing it with a graph visualization tool. With that, let me maybe stop sharing, Denise, and you can show a demo.
Thanks, Nellie. I just wanted to make a quick point before I started. You mentioned that PGQL worksheet is in 23.2, but I think you meant 22.2.
Oh, I apologize if I made a mistake on the version. Okay.
All those versions come together, but I just wanted to put it in the recording. Okay, let's get started here. Okay, so as Melly has shown us already, I'm going to show us how we would create a property graph in SQL Developer using a 23C database. I'm going to show us a PGQL property graph as well as a SQL property graph so we can see the difference between the two. Okay, so let's get started here. So I have a 23C database, and I'm using my SQL worksheet. So I'm going to copy a query, and all this query does is creates a property graph called bank graph, and creates the vertex tables and edge tables that we need for our property graph. And if this kind of syntax is new to you, we have many other Ask Tom sessions that we could send to you if you need that. Okay, so we've created this property graph called bank graph. And we see here that it's been created. And oh, I should point out before that before I started this, I created a couple tables called bank accounts and bank transfers, which we reference here. Sorry, let me step back a bit. And let us create this query. This query is going to fetch us the first 10 rows of the account numbers here in their number of transfers. So in banking systems, you might want to focus mostly on the accounts with the highest number of transfers if you're trying to find any issues with fraud detection. So this would be a quick query that you would run there. And let's see what this would look like in property graph. So if you're running 19C and you need to use the property graph PGQL function, or if you're running 23C and you're transferring older property graph statements that you had in 19C, you would come down here to the property graph folder and click Open PGQL Worksheet. And we get our PGQL worksheet here. And we can create a PGQL type property graph. And I've named this property graph PGQL, bank graph PGQL, so we can see the difference. But you can tell that these queries these statements look very similar. And we've created this graph as well. And this time I'm going to find the top 10 accounts with the highest number of transfers, which we already showed. And again, this can help us identify accounts, which we should focus on when trying to identify identity fraud. And you can see that we got the same results as before. So 387 and 934 have the highest transfer accounts. So if I look back here, we can see that we got the same results. If we want to move a little bit further, we could also find some information like a 2-hop query, which can help us identify accounts which may be used as dummy accounts or used to hide transfers. So if I ran this query, we can see again that 387 and 934 have a significant number of in the middle transfers. So I will continue to use these tables as we move forward later in the presentation.
So that's the interesting thing, Denise. I mean, you have one set of tables and you created a graph that you can query with SQL that we call SQL property graphs, and a graph that you can query with PGQL for PGQL property graphs.
Right.
And typically, depending on your database version, you would choose that one. Yeah.
Correct.
And I think the other thing this highlighted was that on a 23C database, you're still able to create a PGQL graph. And so folks who are upgrading from 19C to 23C don't have to worry about losing all of their work. They can continue to use PGQL graphs.
Yeah. Thanks, Millie.
So do you also plan to show a graph visualization?
Yes, I thought that we were doing that later in the demo. Do you want me to do that right now?
Yeah, maybe we could Yeah, why don't we do that right now?
Okay.
To talk about it, if that works.
So let me just bring that up. Sorry, I wasn't prepared for that just yet.
Oh, well, we'll give you a few seconds. If it doesn't work, I can continue and we can come back to this.
Nope, I just need to log in. Okay. Okay. So here is my graph visualization instance. I've already logged into our user, and we can see here that I have 3 different tabs at the top, one called Graph Server, Data PGQL Property Graphs, and Database SQL Property Graphs. So I'm going to focus on these 2 tabs here, PGQL Property Graphs and SQL Property Graphs. And what we're going to see is I can create very similar queries using PGQL Property Graphs and SQL Property Graphs and get the same data. So I'm already in the PGQL table, so I'll do this one. And why don't we visualize a small sample of the graph? So if I run this query, we can see the all the connections between our nodes, and I can even look at the data here like this. If we wanted for some reason to see the transfers in table form, and then I can show that same data in a SQL property graph. And we're looking at the same data, and we can see it here as well.
And if you click on the settings, I guess we can just quickly show them maybe the showing how they can display the other information about the nodes and the edges.
Yeah, let's do that. Okay, so here's our settings functionality here, and we have all kinds of different things that we can do. So why don't we go to customization, and I can change the theme from light to dark, change the edge marker from an arrow to not. So if I want to know which way the transfer is going, I could use the arrow. If it doesn't matter and it makes the graph a little busy, I could take that out. And we can collect similar edges if we'd like to. One thing that we can do is change the layout. So currently we're using force. I haven't tested this. Let's see what it looks like in hierarchical. This is not going to be particularly helpful to anybody, but maybe we could look at random for fun, or even concrete. Isn't that pretty? Concentric. Okay. And then we can go over here to highlight, so you can create some highlights. So why don't we add a new condition and change our balance to greater than 150,000.
We might not have a balance. Maybe you need to go 1,000, 1,500,000 or something.
I'm
We
sorry.
may not have a balance. That's high in the data. That's all. Sorry.
15,000. Thank you, Melly. And why don't we change the color to red? So we'll see all of the nodes with balances higher than $15,000 and create that. So I'll see quite a few. And then we can maybe create a different highlight called label. And am I doing this wrong?
I think you can go back to the customization and then you'll be able to display the labels there.
Thank you. That's what I was thinking of. Okay.
So scroll down further.
Yep. Okay. This is
right there, right there.
Okay. So why don't we change our label to
or ID or name.
Yeah. Let's do name. And we can see all the different names here. So if we pull one of these out, we can see it a little bit better. It's still very small, but we change this to 10, we'll get a better view. And we can see all the labels here.
Yeah, okay. Yeah.
Anything else you wanted me to show, Melly?
No, I think this is great. Thank you. So let me go back to this here. So it's the demo. Thank you, Denise. So we talked about queries. We talked about visualizing queries, the results of queries rather. So now what do we need to do is run, let's say we want to run a graph algorithm. So when you're using 19C to run a graph algorithm, you're required to have graph server, because that is the only place where you can run graph algorithms in 19C. In 23C, in 23.4, that should be coming out soon, you can you still require graph server to run graph algorithms, but to actually include the running of graph algorithms in the database is on the roadmap. So again, here's an example of running a graph algorithm. This is a Python or maybe Java API would look the same. What's on the roadmap is when we say run this in the database, we plan to add this to SQL. So again, just like with graph visualization, it's the same thing. You install the graph server and you point it to the database. But since you're running the algorithms in graph server, you have the step of you need to load this data or load your graph from the database into graph server. So you need to size your graph server accordingly, that it has enough memory to fit your graph. So when you're using graph server for graph visualization, the graph server is just doing a pass through. It's accepting queries from REST and then sending it to the database and so on. But if you're actually running algorithms in your graph server, you should size the instance accordingly. So install your graph server, point it to the database, and then perhaps you also here it's when you start looking at using some of the graph client libraries. Because if you want to run, let's say in your Jupyter notebook, you want to run a PageRank algorithm on a graph, you want to use Jupyter as your UI for interacting with graph server, you would import this Python client library, and then you'd have access to the APIs. You can both run PGQL queries, or then you can also run graph algorithms. So the use cases for graph server is, like I said, in 19C and earlier, it's primarily for running graph algorithms. And of course, you need it for the graph, you need the install of the graph server for graph visualization. But in other ways, in other cases where you use graph server is to run graph algorithms. So I mentioned that this is on the roadmap, adding graph algorithms to SQL, but we'll add some of the algorithms, some of the popular ones. There'll always be some algorithms because we support over 60 algorithms. There'll always be some algorithms that will not run in the database. And for that, you would always need graph server. And as I mentioned, you create a copy of this graph. So you're kind of loading a snapshot of this data, a point-in-time copy of this data into this graph server in the mid-tier, because the graph server runs in its as a separate instance. It's not running in database SGA. It is set up as a mid-tier server. It runs a separate instance. So you copy your graph from the database into this mid-tier server, and then you can run graph algorithms on it. And we have APIs to synchronize, like your database could keep getting updated. So you can periodically synchronize the data in the database with the copy of the graph you have in graph server. So when you're running queries and everything is in the database, you don't have to worry about the synchronization because it's all in the database. But in the graph server, you have to keep in mind, if you want to synchronize your graph, you have to use the synchronizer API. This is some folks synchronize their graphs like once a day because they're just doing analytics. Some folks synchronize their graphs maybe every 10 minutes and so on. So with that, let me hand it back to Denise for a demo. You're on mute, Denise.
Thanks, Melly. So for this demo, we're actually going to show a video from our colleague, Raul Tasker. And he's going to show us what a PGX operation in Python will look like.
In this demo, I'll show you how you can run graph analytics using a 19.
I just want to make sure you can hear Raul, correct?
Yes.
I could, yes.
Great.
The Oracle database with Graph Server. To get started, you need to use either the Python or Java APIs. Here I'll be using Python, so I have a Jupyter notebook open. Once you install and import the necessary packages, you can create a JDBC connection and then create a PGQL connection from that JDBC connection string. Once that's done, you can run in-database PGQL queries. Here I'll be using the movie recommendations graph, which comes from the movie stream dataset. So here we can run queries like, what are the movies that are available to us in this dataset? And we can print the result set here. We can also ask questions like, what are the names of people who have watched different movies? So here we can list out what is the customer ID, the first name and last name, and the movie that they've watched. And we can limit that result to 10, and we can see the result outputted here. Now that we've run some queries, let's run some analytics. First thing you want to do is create a graph server session and connect to graph server. Once that's done, you can copy this PGX session string and use it to connect to your graph visualization tool later. But first, we'll want to load the graph into memory. We'll create an in-memory representation of the graph to run graph analytics. So in this paragraph, we'll successfully load the movie recommendations graph, and then we can run graph algorithms. Here we want to run the personalized salsa algorithm, which requires a bipartite graph. So first, we'll create a bipartite subgraph and call it BIP graph. We'll run a query specifically for Emilio's vertex. We'll set the cursor to the first row to get that vertex, and then we will get the element by its name. Then we will run the personalized salsa algorithm on that specific vertex, meaning on Emilio's vertex for the bipartite graph, and that will create a new property that we can query from this in-memory representation of the bipartite graph. So here we can ask questions like, what are the movies that have the highest personalized salsa scores that were not previously watched by Emilio? And we can see the results here. And this would indicate that these are movies that we might want to recommend to Emilio, such as Avengers Age. We can then see who are the customers that have similar viewing habits to Emilio, or what are the customers with the highest score or rank. And we can see that Timmy Gardner, Blanca Diaz, etc., have similar viewing patterns to Emilio. This could indicate that Emilio might want to watch the similar movies as these customers. So then we can find the movies that have the highest personalized salsa scores that were not previously watched by Emilio. And we can see things like Home Alone, Guardians of the Galaxy 2, etc. Now let's hop over to our graph visualization tool, and we can run queries on this in.
Okay, so in this part, Raul's just going to go over the same thing that we just did. So, Melly, is there anything that you'd like to highlight?
No, thank you, Denise. That was great. Let me just talk quickly about, the fact that the personalized salsa algorithm that Rahul was showing was, you can see that it's a simple API call, so you don't have to do anything complex. It really becomes very easy to use this by data scientists or data analysts to use this tool to work with a graph in a Jupyter notebook. You would have noticed that Rahul was switching for visualizing the results. He was switching over to the Graphist tool. He was not using Jupyter. So that's on the roadmap to enable graph visualizations within a Jupyter notebook. But then you can also, I'm also going to be showing you our graph, the notebook we have in Autonomous Database where the visualization is integrated. But before getting to that, let me kind of do a recap here of what we have seen so far. You have autonomous database deployment, and we have deployment of the base database service and the on-premises deployment. So what we have talked about so far is which is the installation of Graph Server and the use of Graph Client, use of the Graph Visualization tool. These are the typical components that you would deploy when you are using a database as a base database service, and either in the cloud or on premises. And it could be an Oracle Cloud or Oracle Database at Azure or Autonomous Database Dedicated. All of these components. So basically you have a database and you have these other graph libraries and tooling that you would install and use with these databases. And on Oracle Cloud, to make this install simpler, we have a marketplace image that includes all of these things, includes Graph Server, includes Graph Client, includes the bits needed for the Graph Visualization tool. So you can install this in a few clicks. So you have a base database service. You can access this marketplace image, deploy it in a complete VM, and then have it point to your database all with a few clicks. So it makes it really easy to deploy all of these things in Oracle Cloud. If you're using this database on premises, I mean, there are a few more manual steps involved, like you would download Graph Server and Graph Client from the Oracle Software Delivery Cloud, and then install them yourselves in your own machine. So now let's come to the autonomous database, which is kind of where everything kind of comes together. So when they have the base database service, we have made it simple to install Graph Server and Graph Client and so on. But what if you didn't need to do any installation at all? What if you could just combine everything together, the database with the Graph Server, so that when you provision something and deploy, and when you provision something, you have all the bits in place. You don't have to install anything. And that's what the autonomous database serverless option provides for you. It has integrated Graph Server, it's integrated all the tooling that you need. So when you provision an autonomous database, you already have this. When you spend a minute to create an autonomous database, you have access to Graph Studio. So that's the name for all of these tools that are integrated together with autonomous database. We have access to Graph Studio, and the Graph Studio has various these tools integrated, and it is additional automation as well for automating the modeling of a graph. And it has a notebook where the graph visualization is integrated. So let me quickly kind of show a demo of that. A second here. Okay, so this is my autonomous database console. And this is just, I didn't do anything special. This is just a regular autonomous database deployment. And right when I do that, I have the ability to invoke Graph Studio. You can also pull that from the database actions page. But anyway, I can invoke Graph Studio. And here I've logged into Graph Studio using a graph-enabled user. So within Graph Studio, you can see here, let me start with home. You have the ability to create graphs, to use a specialized notebook that's part of Graph Studio with these graphs. So I can go to the graphs page here. I can look at the list of graphs that are available. And then if I want to create a graph, here's where the automated modeling comes in. I can create a graph. I can say bank graph as Tom. And then I can go ahead and I can select the tables that I want to include as part of this graph. So like Denise is working with the bank accounts and the bank transactions table. I'm working with those two same tables. And then when I click on next, basically the automated modeler looks at the primary key information, looks at the foreign key constraints, and identifies that this is potentially a vertex table and this is potentially an edge table connecting the different bank accounts. And I can go and look at the source here. This is the source that Denise is running earlier in SQL Developer. This source has been generated by this automated modeling tool. I can preview the graph itself, and this is what it looks like, bank accounts connected to each other using the bank transactions relationship. And I can go ahead and then create a graph using what the automated tooling has provided. So I'm not actually, I could just create a graph, but I'm not going to create the graph right now because I already have a graph created. So I'm going to switch here to notebooks. And let me bring this particular notebook up here. So you might have noticed that in Rahul's demo, when he was loading into the graph server in Jupyter, he ran code that was kind of similar to this, which loaded your graph from database into graph server. And in Graph Studio, it's all part of the same it's part of autonomous database instance. You access this notebook from your autonomous database instance, like I just did. And then this graph is loaded in memory. I just loaded it just before our session started. So let me now go and we can run some queries. And this is again, this very similar query to what Denise was running. Let me change this to the force layout, which she had earlier. And you can see that it looks similar. And I can again, we had the name. This time, let me choose an ID. No, I want to choose the account ID. And then I can get its label could be the amount that is transferred and so on. So I can look at the graph. So the visualization is integrated with your notebook. And similarly, there are other queries that I can run here. I can say here that, okay, I'm looking for all cycles that start with this variable. Variable is 534. And which are 1 to 5 hops long, and so on. So you can keep, there are various queries I can keep running this way. So I'm sure you've seen Graph Studio in many other demos and sessions we've done. My whole point is to here show how Graph Server, Graph Visualization, and all of these tools are integrated in Graph Studio. So when you provision autonomous database, it's all available for you. So let me again highlight the use cases. So when do you use Graph Studio in Autonomous Database Serverless? So even if you don't have a plan to use Autonomous Database right away, it's still useful. It's a really useful tool to get started. You can just play around with graph queries, and all our LiveLabs use autonomous data. Most of our LiveLabs use Autonomous Database Serverless. It takes away the issues of I don't need to install, I don't need to worry about anything. I can just start working with graphs right away. It's self-service in the sense that you don't have to talk to your DBA about getting access and so on. If you have credits, you can start using this right away. You could use it with the free tier instance as well, particularly on the database side. I mean, the resources are a little limited on the autonomous database, always free instance, but that is something you can try for in database queries. And the automation of graph modeling makes it simple. If you're just getting started with graphs, it's helpful to have that assistance in creating your graph. And the notebook with advanced, with integrated visualization is also very nice. You have the visualization right there. You don't have to go to a separate tool. Now, if for some reason you wanted to have an autonomous database, but use your own application, like rather than using the notebook, you might want to have an application interact with Graph Server and autonomous database. You could do that. We do also ship the client separately. Like if you're using Python, you can get it from PyPy, or if you're using Java, you can get it from Maven. You can get these clients and integrate them in your application so you can interact with the autonomous database through your application. And in some cases, occasionally folks like to deploy their own graph server. I mean, there is a graph server instance integrated with autonomous database. I mean, it runs in its own compute instance, but you don't have to worry about configuring it to connect to the database and so on when you're using the integrated Graph Studio with autonomous database. But if for some reason you want to have your own separate graph server because you want to run it in your own on a separate compute instance, you don't want to use the instance that automatically autonomous database provisions for you. You want to use your own compute instance. Maybe there are some size restrictions, or for whatever reason, if you want to have your own graph server, that's possible too. You can use autonomous database and you can set up your own standalone graph server and communicate with the autonomous database. So with that, I've come to, I think, what Denise and I wanted to share here. Here are some resources, and I apologize, I have this long Ask Tom link. We'll try to make it shorter, but if you go to Ask Tom series and look for graph, hopefully you'll be able to find us. And we do want to make this series a regular event. At least we want to have something new to talk about, something interesting to talk about graphs every month. And the LiveLabs that I talked about, where most of them are supported on Oracle database, autonomous database serverless, they're all available for you to try. So you do get an autonomous database instance for a few hours that you can use to run the LiveLab. We have a YouTube channel, and we have blogs. We blog on oracle.com. We also blog on Medium, like the Getting Started with SQL Developer, Getting Started with GraphViz that I showed very early on. Those are available on Medium. So I'll leave the screen up while we see whether there are any questions that it would be interesting to answer live. Are there any questions, Denise?
We haven't had no questions, Molly.
I saw there's a question earlier because of the SQL Developer version stuff. So, okay, this is a time to, I think we still have about 10 minutes. So we'll hang out here, and if you have any questions, please do ask them. And I hope this session made some of this components clearer, and it made sense about what you should start looking at if you're going to start working with Oracle Graph using your particular scenario, which might be on premises, it might be on the cloud, it might be on Azure, it might be autonomous database serverless, whichever. So Denise, let me ask you, when you started working with the team, did you find all of these components just a little bit confusing?
Absolutely. I mean, I think that this, when I started, would have been invaluable. So I think it's a great resource for us to have. It did take me a while to understand what all the different components meant and how we use them and when you need what. So I think that this was really great.
Right. And we keep trying to make all of this simpler. I mean, the reason there are all of these components is because there's so many different deployment options. I mean, whether you deploy on premises or an OCI or use autonomous database serverless. I mean, they are different environments with different requirements. So we keep trying to make them simple as possible.
Right. We have gotten a couple questions.
Okay.
The first one is this solution better than Neo4j?
Well, you're asking someone who's a product manager for Oracle Graph. I'm going to say, yes, you are better than Neo4j, but let me qualify this answer a little bit. So I'm not just saying it because I work for Oracle, but it's because we have taken a fundamentally different approach, which basically in the sense that we are very much integrated into the database, which can do many other different things as well.
Mm-hmm.
We don't believe that having a siloed graph database is very helpful for users. It might be helpful for some tasks, but often as an application grows and adds more features and gets more complex, developers need to work with many different data types. They need to work with not just graphs, they need to work with relational tables, they need to work with spatial data, JSON data, and so on. So it's really helpful to be able to work with all of these data types together. And the other nice thing about Oracle Graph is you don't have to move your data anywhere. I mean, you can if you want to. I was just talking to a customer yesterday where they said, we don't want to touch a production database. So we'll just create a separate database instance and copy some data there. You could if you wanted to, but you don't have to if you don't want to. You can just create this graph view on your production database. It should not impact anything else. And then you start working with graphs. So having one single source of truth for all your data makes life a lot simple. So I think these are the two key areas in where I think we're different from other siloed graph database vendors. So shall we read through a couple of questions? I think the first one, there's a question on how do I apply machine learning? That's a good question. We didn't touch upon that at all. The 60 plus graph algorithms that I mentioned includes graph machine learning algorithms, such as DeepWalk, PG2Vec, and GraphWise, which is based on GraphSage. And these learning algorithms, these machine learning algorithms give you a way to create embeddings of the nodes in your graph that take into account how the nodes are connected to each other. So you can get this additional information about your data based on these connections, and that gives you larger information coverage, which also can mean that you get more accurate models for making predictions. And also, if you use something like GraphWise, you're using like a graph neural network, which uses convolutional neural techniques for going through different layers and kind of aggregating information about a node from the nodes surrounding it and so on. So we absolutely have graph machine learning algorithms, and that's an area of investment for us. And I see another question, is there any graph plugin to Apex available? Yes, there is. In 19C, you do need to use Autonomous Database Serverless to make use of the Apex plugin. In 23C, any database you can use the Apex plugin with. And we have actually an Apex Office Hours video on YouTube that you can look at. So if Denise or Ramu, if you have that link handy, you could post it. Rahul did this. Apex asked Office Hours on Apex plugins for graph. But yeah, you can access our resources and find some information about the Apex plugin.
Shall we plug Ramu's Apex graph Asked On session on Thursday if you're a Spanish speaker?
Sure, that's except it's on graph, but go ahead and, sorry, it's on spatial.
Oh,
Go ahead.
I'm sorry, that's true. Ignore me.
But what's an interesting point that you raised, that we are expanding into other languages, in the sense that we have some of our blogs. I think the initial blogs that I talked about, Ramos also written them in Spanish, and we have some videos in Spanish, and the Ask Tom Spatial Office Hours. Ramu is doing a Apex plugin, and that's a Spanish session, and perhaps we'll plan a graph session in the future as well.
Okay. And I'm putting in the link to the Apex and Property Graphs in 23C link into chat right now.
Okay. Thank you, Dennis.
You're welcome. Anybody else have any questions?
Well, if there are no other questions, we can perhaps consider wrapping up. Anything else you would like to add, Denise?
No, thank you, Melly.
So thank you very much for joining, everyone. I hope you found this useful, and stay tuned for new sessions in the future. Thank you.